Hello everyone, our today's topic is congruence of triangle. In our daily life, we generally come across objects which look identical in shape. If two figures are such that they have same shape and size, they are called congruent figures. For example, a 100 rupee note. There are two 100 rupee notes actually, but when they place one on the other, one hide the other completely. In a similar way, if we take this bowl and one more bowl, they are congruent in shape. If we put one on the other, they hide them exactly. Two coins of 2 rupee notes, if placed one on the other, they hide them completely. Therefore, we can say two figures are congruent if one figure superimposes the other figure. So in this case, we find it that this circle and this circle shape, if put one on the other, they hide completely each other. They superimpose each other exactly. It means the two circles are congruent. But if I put this small circle with different radii, so they are not hiding each other completely because one is smaller than the other. This is a square, and if I put this square on the other square, it hides the other square exactly, so they are congruent squares. We can say here that two circles are congruent if they have equal radii, and conversely means vice versa. And the two squares are congruent if they have equal sides, or conversely. Conversely means here that if we say like two squares are congruent, it means their side must be equal. And if sides of the square is equal, it means the two squares are congruent. Two triangles are congruent if pairs of corresponding sides and corresponding angles are equal. For example, triangle ABC is congruent, this is the sign of congruency, congruent to triangle DEF if their corresponding parts, that means sides and angles, matches with each other. So in case of congruence of triangles, it is necessary that we must match the correct vertices. Since a triangle has 3 angles and 3 sides, so there are 6 matching parts in case of triangles. However, we shall learn that it is sufficient to match only 3 parts of one triangle with corresponding 3 parts of the other triangle, and which includes at least one side. While superimposing triangle ABC on triangle DEF, we can see that vertex A will overlap on vertex D, vertex B overlap on vertex E, vertex C overlap on vertex F. And in the same way, AB side coincides with DE. So it is written in this way. ABDE, BC matches with EF, CA matches with this. These are the 3 sides and these are the 3 angles which matches with each other. And we can find it with the help of this way also, like A vertex will match with D vertex, B to E, C to F. And there are 4 cases of congruency of triangles. I will explain them one by one. The cases are SSS congruence, SAS congruence, ASA congruence, and RHS congruence. Here we can note that S, S, S and S, at least one side is necessary. It is also written here, 3 parts are sufficient to match to prove the congruency of triangle, which include at least one side. First case is Sss Congruence. By its name only it is clear that side congruence it is. Two triangles are congruent if the three sides of one triangle are respectively equal to the three sides of the other triangle. We have an example. Triangle ABC, triangle DEF. So here AB is 3 centimeter, DF is 3 centimeter, AC is 5 centimeter, so DE is 5 centimeter, BC is 6.2 centimeter, and FE or EF is 6.2 centimeters. So here which vertex will match with vertex, we have to first find it out. To find the right vertices match, this exercise will help us. Here we know AB is equal to 3 centimeter and DF, which can also be FD. So I have written both. It is equal to this, either this or this. AC equals to 5 centimeter, which can be equal to DE or ED. So I have written both. Now we match. A and D will match here. A and D will match here. When I take this F, so A will match with F and A will match with E. The two different letters are matching. The only matching letter is D. That means D vertex will match with A vertex. So here I write D as a matching part for vertex A and A as a matching part of vertex D. And similarly, we come to know, because this is the right match, so we cross them and we take that B matches with F and C matches with E. So we write down them in a circle. In the same way we write it here. And we come to solve this question, we write it in this way. Like AB is equal to DF, which is given to us. This is side given equal to this side. Then AC side matches with DE side, which is written here. BC side matches with FE side. So we can say triangle ABC is congruent to triangle DEF by Sss congruency. It means side congruency. Case 2, SAS congruence. Two triangles are congruent if two sides and the included angle, two sides and included angle of one triangle equals to the two sides and the included angle of the other triangle. Triangle ABC is shown here and DEF is shown here, where we can see AC side matches with DF side, angle A matches with angle D, and AB side matches with DE side. So we can solve it in this way and we can come to know this is side angle side congruency, because two sides and angle between them, the included angle is there. So side angle side congruency is present here. Case 3, ASA congruence. Two triangles are congruent if two angles and the included side of one triangle are congruent to the corresponding angles and sides of the other triangle. For example, ABC triangle and PQR are the two triangles given here, where we can see 40-degree angle, included side AB and 60-degree angle are present in both the triangles. So they are congruent by angle, included side and angle. So ASA congruency is here, and this can be solved in this way. Note that AAS can be changed to ASA type by ASP of triangle. Third angle can be determined. Now what is this? AAS. It means if in one triangle the two angles and included side is given, but in other triangle the included side is not present, the two angles are there. That means angle, angle and side is given. So what we can do with the help of angle sum property, ASP of triangle, we can find the third missing angle here. Like this is solved for you. So we can find angle P here 60 degree. So we can find this 60 degree here, and automatically what comes, that this angle and the between side, involved side and one angle has appeared, which is the same 60 degree and 60 degree like the previous one. So we can prove this, and we can change AAS type of congruence back into ASA type congruence. Now fourth and the last congruency, RHS congruency. By its name it is clear that it is talking about right angle triangle. Two right triangles are congruent if the hypotenuse and one side of one triangle are congruent to the hypotenuse and corresponding sides of the other triangle. For example, ABC is a triangle given and PQR is a triangle given. So R stands for right angle, H stands for hypotenuse and S stands for side. Let's see whether these three elements are present here. AB side, BC side and AC side. AC side is just opposite to right angle. So this side is hypotenuse and this is one side given and we know it is a right angle. So we can see the same is happening in the second triangle also. So yes, we can say angle B equal to angle Q, which is 90 degree. BC is side which is equal to QR side. And AC side which is equal to PR, which is nothing but hypotenuse. So three elements are there: right angle, hypotenuse and side. So we can say these two triangles are congruent by RHS congruency. Now if in this same question I ask you whether angle A is equal to angle P, though the measurement is not given, so what we can do? So there is one helping thing which is said corresponding parts of congruent triangles, that is CPCT, short, corresponding parts of congruent triangle, CPCT. It says that if the two given triangles are congruent, which we have already proved that two triangles are already congruent, we have proved. So we can say it's all the elements, like all six elements means three sides and three angles, they are also congruent. So this is saying that and nothing. It says that two triangles are congruent. It means their corresponding parts, like angle A equal to angle P. If we ask whether AB side is equal to PQ, yes, we can say yes by CPCT. Thank you for watching.